Hello, welcome to the lecture 4 of first chapter Physical World of the Intermediate Physics. My name is Dr. Hemant and you are watching Learning-Riti. So in this lecture we will see the fundamental forces in nature, what are these fundamental forces and some specification about them. So these fundamental forces we are talking about: gravitational, electromagnetic, strong nuclear and weak nuclear forces. So before we go to that, what is the fundamental forces? So we all know that we come across different kind of forces in our daily routine. For example, once you push something, when you throw something, or when you want to carry something, then always there is a force. We have to put energy, the force is required to throw or push or pick up something, right? So these are all forces. If you talk about macroscopic world, then we have a different kind of forces. For example, muscular force, contact force between two surfaces, friction force, when you elongating springs or the compressing a spring, there is a force required. Fluid, for example, once you throw jet of fluid, water, then you feel the pressure, the force you feel there. So there are different kind of force. Even if you talk about microscopic level, then you can have a forces, for example, nuclear forces, which involves electron, proton, neutron, intermolecular forces. So all these are the forces which is we see in our daily life. So now talking about that, are these all forces are of different type? For example, friction force or muscular force, or can we have a more generalized way to derive all these different kind of forces we are talking about from some fundamental forces? So actually in the recent time, the current physics level, we have 4 known fundamental forces, and all these forces can be derived from those. We talk about physics, then as we have seen in many times, I have said in my previous lectures as well, that in physics we try to make things simpler and simpler. We try to solve the more complicated problems using the basic fundamental principles of physics, and we try to explore those laws. So similarly, in this case of force, we are moving towards unification. Our approach in physics is that to come up with that model, a theory or explanation with all these kind of forces in one single theory for now. But right now we have not reached to that level. But as of today, the current situation in physics, we have 4 fundamental forces which can be used to define all different kind of forces which we see in our daily life, in either it's a macroscopic level or microscopic level. So let's see how and what all these fundamental forces are there. The very first fundamental force is the gravitational force, and this is also a very you can say universal force. So why this we call it as a universal force? Because every object in the world, in the universe, feels this force, and this is nothing but it is because of the masses of that actual different body have masses, and because of that they exert force on each other. So when we talk, for example, the motion of Earth, the moon around the Earth, artificial satellite moving around the Earth, and the Earth itself moving around the Sun, this is all result of the gravitational force between the two bodies. In case of Sun, Earth, it's the gravitational force of Sun which is just holding Earth in its orbit, and similarly Earth gravitational force which is holding Moon its own orbit. So this is, you can see that even two objects. Now as I said, it depends upon the mass. The heavier the mass, the heavier the gravitational force. So if you talk about the characteristics of it, so it have all the objects in the universe feel this gravitational force, and the range is infinite, means infinite distances between the two will exert the force on each other, how far it is. It is different thing that whether you are able to feel it, means what is the relative strength of this force, that is a different matter, but definitely there is a force, like you are feeling the force from earth, ground, and also from the sun you have certain force, but you are not able to feel that way, and the stronger you feel for the earth, because the distance is huge, and of course the mass and distance, as I discussed in my previous lecture, that proportional force is gravitational force is proportional to masses and inversely proportional to distance square. So now talking about there are four fundamental forces, and if you talk about relative strength, so consider that the gravitational force relative strength is 1, and then we will see relative to this gravitational force how the remaining three how stronger they are. So this is all about the gravitational force. Now let us move to the next force, which is electromagnetic force. So electromagnetic force work between the charged particles, all the charged particles, if this is static, then the Coulomb force between them work, and it also depends upon the charge, type of charge. This is the positively charged, the force between the positively charged particle will be always repulsive, and the force between the opposite charged particles like positive and negative will be always attractive. And it is quite different from the gravitational, which is not charge dependent, it is like mass dependent, but here in this case it is a charge dependent force. And talking about the different characteristics, then it have also the strength range, means two particles having at infinite distance can have the electromagnetic force between them. Of course the relative strength will change depending upon their charge, quantity of charge, and the distances between them. And as I said, it is different from the gravitational because it can be either repulsive or attractive, but gravitational force is always attractive. Now talking about relative strength, then it is 10 to the power 37 times more stronger than gravitational force. So if there are two at the same point of time, if you are having gravitational force and electromagnetic force at in a given distance range, then you will feel the electromagnetic force is much stronger than gravitational force. Let me take an example, and the example is like let's say this is the object and I am holding on my palm, right? So when I am holding on it, so I am feeling a force downward, that is the gravitational force, but of course then you can see that I am feeling it, then where is the electromagnetic force? Both are having an infinite range, right? So the fact you can notice is that you are still feeling the force, but consider that your palm and the surface between this object and your palm, the constituents particles like the hands, there are many small, you can consider that small particles are there, they are working together, and forces between them working together there. So assume that if those forces between these objects constituents particles and my hand palm constituent particles and between the surface, if those forces, gravitational force would have been stronger than that, then these hand would have been just gone away, and that object would have fallen down, but it is not happening, right? It is still holding on it, and I am feeling that. So now you can see an example like how that electromagnetic force between the constituents between this object or of my hand are working, and how they are stronger than enough that the whole hand, my palm and the object is still intact, and I am just feeling the pressure which is of the gravitation. So this is, you can see the relative strength, how it is important and how it is able to hold things, and then we are able to hold these object as a whole, not as a parts. If the force is higher for the gravitation, then you could not have absorbed this as a complete object, would have been scattered in particles, parts away. So this is a very nice example I think you can think of the relative strengths of the electromagnetic and gravitational force. So let's see the next force. The third force is the strong nuclear force, and this is the force which acts between the nucleons like electron, proton, neutron inside the nucleus, and also lots of other elementary particles. And this is the scale of at the nuclear scale, then they are a short range forces which works within this 10 to the power minus 15 meter range, which is the scale of the nucleus and atom. And talking about relative strength, then it is 100 times more stronger than electromagnetic force, but the only catch here is that it works only at a very limited scale. It's not like electromagnetic, which is have an infinite range. It is working at a very short distance range. And the very other important aspects I would like to tell you about a strong nuclear force, that it is again a charge independent force, means the strong nuclear force between electron proton, proton neutron, or electron neutron will be all same. It is not like all attractive and same, and it is not going to vary depending upon the charge. And now moving to the next force, which is weak nuclear force. So this is again further works between the elementary particles, electrons and neutrino, and it is even works in even shorter than the strong nuclear force, and means this is order of 10⁻⁻16, which is a subnuclear size and very elementary particles you will see. And of course maybe these are the forces you may not read it in detail in your intermediate courses, but once you move further in your higher education you will get to know more and more about it. But for the time being, talking about the relative strength and the different quantitative qualitative approach, then this is less stronger than the strong nuclear force and electromagnetic nuclear force. So as we have seen that the relative strength for gravitational is 1, for electromagnetic 10⁻37 times than gravitational. Then when we talk about strong nuclear, then it is 100 times of that, and now this is 10⁻26 times. So you can see that the strongest one is the strong nuclear force, then you have electromagnetic, then you have weak nuclear, and then fourth number is gravitational. But this gravitational force is universal force, and it is mass dependent, and electromagnetic force is again having an infinite range, but it is very much charge dependent. And these two forces, strong nuclear and weak nuclear, are forces which work in a very short range. So this is all the 4 fundamental forces which is used to explain all kind of different object types, different types of forces we see in our daily life. And for the current scenario, these are the forces which can explain everything. Now we'll see in our next lecture the next topic, nature of physical laws.